How's it going, everyone? Welcome again. Euler Gonzalez here, talking right now on the rethinking in asynchronicity. Give me a second because I need to shut the kitchen doors. All right. Yeah, much better. Well, right now I am. It's laundry time, right? So yes. All right. So what we really care about in today's video is looking at this rethinking asynchronicity in JavaScript. Why we're looking at this? Because this is a course of the advanced Redux and how do we get here, right? So as a way to make these things very quickly, okay, the TLDR is because at the end of the day, the problem that Redux actually solves is by using now this architecture, this way of building, is how we're gonna manage our state. Specifically, how we're gonna now make our data in a consistent state. And also we can have the ability to what's going on when something is mutated, when something changed. So we know what went wrong or what happened. Okay, so the point of this is that the vast majority of these applications right now that use some sort of state management, right, whether it's Angular, React, or Vue, right, so all of them now realize that they need to find a way to manage the state, to manage the data, and at which version the data it is, right? Why is this? As a way to now have control of what happened and when the data is mutated, so we can now have a record of what's happened. And not only that we, especially when we need to build this application as a way to talk to other computers, okay, and then we have therefore wait for those response, because if you think about, there's a way to recap briefly of the computer architecture. So you have now the CPU that it needs some sort of way to store information quickly. That's what you have now, cache. So cache level 1, level 2, level 3, and those operations that can, or those space, or those operations that we can do a little bit later, all right, that we don't need to actually access to them quickly. So for example, is if you want to go out and try to buy groceries, you want your key in a quickly place, in a place where you can access them quickly. So that's why we have, for example, this cache, right, as a way to operations that we want to do that are frequently, we want is to now a cache. So then we have now the main memory, all right. We also have to wait for that, which it can be seen like, hey, this is now some sort of backpack that you have, right? You have to now take off of this and then open up, look up what are the things that you want to go with or get it, and then you actually do what you want, or what you need. So the whole point of this is that at each one of those places, whether it's cache, main memory, disk, and all the computers that actually contains all of those documents, store not only main memory but also is on their own disk. So we have now to wait for this. At some point, it will eventually we will get that or not. So that's one of the reasons why this concept of state management, and also how we're going to handle is data that we have to wait for this when it comes to mutate that state. That's when it comes to understanding now this particularly asynchronicity. And what is the sort of difference between this parallelism and asynchronicity? And how now, for example, Kel Simpson Shout out to Kyle Simpson. Shout out to Kyle Simpson. Oh my God, God bless you, man. Jesus. Mention that. It say, hey, he created this particular course as a way to not only understand the theoretical aspect of this, and then put a practice with code to know what are the problems that we have to face, especially when we need to write these kind of applications on the browser. All right. And what are the areas that we're going to explore as a way to see what are the patterns that we need, and why we need these particular patterns, and what are the problems that they solve. So we can now understand behind the scenes this asynchronicity. And for that, by putting the distinction between parallel and asynchronicity, is parallels are things that happen at the same time. So for example, in the context of computers, which is quite different of the concept of human cognition, right? We are not so far be able to process data in parallel, process, or in this cognitive aspect. Again, I'm not a neuroscientist, but the point is cognitively we cannot handle things in parallel. Biologically, there is a couple things that needs to happen at the same time in a time frame that actually allow us to keep alive. Otherwise, we will vanish. So, in the context of computers, true parallelism is when you are now able to have multiple tasks that are running in multiple threads. All right, so you have now one application in one thread, or one task in one thread, and one another task in another thread, and so on and so on. So but all of this means that you are using now threads for this as a way to process all of this at once, right? So that's introduced now is and the aspect of how now applications actually work, specifically the browser, which is where we're going to most of the time spare our time. So the browser, because it only uses one thread of that, and if you can imagine that multiple processors right now have 16 or 32 CPUs, and that is not enough if you're going to run is an OS, because there's a lot of things, a lot of servers, a lot of management system that needs to be in place to make that OS actually provide some utility function and be useful to the user, as well as now be efficient with the research. So that's quite interesting, because it's also talk about in terms of how do we find value when it comes to actually get things fast. So computers is just a model of how we can do this. And again, by looking now at the browser and how it's now using one threads, and because we are writing JavaScript applications that run in these particular environments or applications, we also have is this single thread application. So all of our instructions are executed one line after another. So in our particular case, when we need to, for example, you have to build an application, and this application is for a CEO that actually now say, hey, you know what, we want is to create now the e-commerce as a way to sell smart TVs. Right, we want to sell smart TV to Kanye West. So well, we design is the interface, we design also the backend. That's for the backend guys. We design is the front end. We also use this a particular library as a way to now handle this last piece of the checkout. Okay, so everything went well. We make our tests, and then we deploy our code to production. So everything went well. Everything is good. And well, that's it. That's it. So suddenly now a particularly person tells you, don't you know that Kanye West was charged 5 times for a TV and now he is on the news whining and screaming about it? And then you receive a CEO, then you receive a call from your CEO that tells you, hey, um, we need to talk ASAP. So you are quite scary about that, and you now tell them what happened, and then he tells you what happened to his client, Kenny, right? So you will now go out and find out what went wrong and how can we fix it. So you look at your code base, okay? You examine that your code base actually works as expected, is doing what it is supposed to do, and then now when you are actually doing the checkout, you see that you're using is this third-party library. So then you do your heuristics. It's a way to understand what's going on in this particular library, and when then you reach that the way how they handling is this asynchronous operation is quite funny here. And they perhaps is copying and pasting this particular code, and they're making some sort of assumptions that are ends up charging Kanye West 5 TVs. So, oh my God, that's not a good. That's assumption are not good. Definitely, assumptions are not good, especially on design, unless you set some sort of constraint for that. So because of that, then you realize what was the problem, then you submit a ticket to the library maintainers, and then now past couple months or weeks as a way to figure it out and debate what went wrong, how they can do that, and then you've now finally identified the problem, come back to your CEO, and then you tell them what went wrong. Right, so now we were using is a particular third-party library that they actually manage that asynchronicity in that particular way. We already tell them that actually caused a particular problem, and that was the problem, and how they can fix that, and that kind of thing. So even though your boss won't make, your boss when your boss hear that, they definitely don't be happy about it. They're still gonna look at you and say, so why you use that third-party library in the first place? Oh, here we go, bro. Here we go. So the whole point of this brief story is to now, especially when we need to actually write this kind of JavaScript applications, how important it is for us to understand not only how the things work, very, very essential, how this tool works, but also how can we now be able to handle with this particular problem, which is the asynchronicity, or in other words, is that this concurrency, to be more specific, which is now, unlike parallelism, where you need to handle this multiple operation at the same time. We don't want to do that. In fact, we want is to now is how can we deal multiple things that overlaps over time, and that's why we need to also look is how can we handle that? What is the problem that we're trying to solve? And what are the particular patterns to do that? That's why we need to have discipline. And this is something go to myself. That's why you need discipline as a way to understand now how your tools works. So schedule time for that. I don't know, perhaps 2 academic hours, hour and a half. Do that. But the whole idea here is to understand how that tools work, what it's doing, what is the problem that you're trying to solve, as a way to get so be disciplined when you need to do this kind of thing, when you need to understand and then come up with some sort of pattern, some sort of design. Yeah, that's also go to myself completely. So the idea here is that when we need to look at these particular examples and how can we handle this asynchronicity as a way to prevent this problems in the future, and how do we need to be disciplined here, and why this is a profession. Even the name itself, when you take a look at the origins of this, it comes from the old French profession, back in 14th century, where back then it was secrets vowed taken upon entering into a religion. In this case, we're not entering into a religion, that sometimes it might feels like that, but you are now entering here into a realm or to a discipline that requires you to do that. And not only that, because that'll also benefit you in how you can solve with your own problems, but also the other ones, the rest of the people. So the TLDR of this is now be able to describe what parallelism, asynchronicity, specifically concurrency, is all about. So be able to describe that is all of these tasks that overlaps over time. All right, so you're doing this kind of tasks, and then there are other tasks that are overlapping over time that you need to handle that, and so on and so forth. So now, with the notion, or in the context of the browser, how can we now run our code, this concurrent code, because we run this application in one single thread, one line after another, and since we don't need to actually handle is this multi-threading programming, since they now have this notion of the event loop, which is, hey, I'm going to now delegate all of these tasks to a particularly or separate threads, and when I have executed, or when I have evaluated this particular file, then I'm going to now evaluating all of these tasks that I need to evaluate during the program. So that's why. So the idea here is that in theory you can express those instances per threads, okay, and simulate parallelism, but they can communicate each other, right? And that's and again, web worker is an attempt to make that things happen. So to close the gap by speeding up an entire new process, okay, or on a thread that can now communicate with all of these different JavaScript applications, JavaScript threads, JavaScript a process, all right, or particularly. So now web workers now wants to close the gap between now allowing you this parallelisms by running is an entire process on the threads of the JavaScript engines, but because these threads can communicate each other's, we use now this web worker as a way to do that. But the platform, again, this is something that is not defined by JavaScript. This is something from the web platform, right? And with that, the good news is we don't have to worry about handling its concurrency or handling parallelism in programs or multi-threading programs, so for example, like taxes and semaphores, and resource locking, and all that wild things, right? So fortunately now web workers allow this communication strap in a synchronous event, so they can communicate is through the event loop, through these notions of all of these operations that we want to do. We want to schedule that to be later on executed. So because of this, and then we have now particularly syntax or patterns where we can now use this event loop or this particular event loop notion of now delegating all of these tasks to someone, in this case the event loops, and then let it all be processed, right? Because the pattern that we have now right now are not capable to express the complexity of the JavaScript application that we're dealing in today's, right, in modern web applications. So that's why we need to actually be disciplined and understand that what are the things that we can come out, what are the patterns that we can come out, and understand those patterns, why those patterns exist, so we can now so we can continue to evolve is not only ecosystem but also our problems. So our level of competency God our level of competency. Okay, so the next level of competency for JavaScript developers or whoever dedicate this as a profession is to be strategic and tactical in your approach of is to be strategic and tactical in your approach. The strategic is what are the things that you want to do in the long run, and tactical is that what are the things that you need to do this quickly here right now, right? So this, and I like and I love that Kyle Simpson actually brought that up, right? So this is the next level of competency, and this is for JavaScript developers. This is back in 2016, because this course is from that. We're talking about is like almost 10 years. Oh my French, does it? Oh my French, does it? 10 years, no, hell, oh my. Almost 10 years actually to finally realize and don't escape from the truth, which is, hey, you need to learn this for your own sake and for the company's endeavors. So yeah, makes a lot of sense. So now, and again, this is back in 2016. I don't know what is the next level of competency that JavaScript developers need to. Maybe is to understand is what are the what are the problems, or what will be is now the vision of writing this JavaScript application now combining with TypeScript. Again, something that is quite subtle, but yeah, the idea here is that if you want to be a competent JavaScript developers, you need to be strategic and tactical in your approach, not only to write your application, which is something that we're doing in other courses, right? What you need to understand is that what are the things that we need to as a way to build this front-end applications, the front-end system design, all right? What are the fundamentals that you need to do as a way to understand this one? And the other is that how you going to maintain those applications with a large range of contributors over a long period of time, right? So we're talking about is now the design and the maintainability, but this is for JavaScript applications, synchronous applications, right? But when it comes to now handle is this concurrency as a way to now communicate, make your application to communicate with other aspect or other part of our applications, or other component of our system or computing systems, whether it's a main memory or the disk or any other computers, all right? We need to now understand is, so we need to understand, be strategic and tactical when it comes to deal with concurrency management in asynchronous applications. Oh my goodness. So key notes of this is first, assumptions can be dangerous. Assumptions can be dangerous. That's why we have now contracts as a way to clarify as much as possible this thing. Assumptions can be dangerous, and because now we are writing these applications in JavaScript that not only is for adding interactivity to web applications, but also to handle is the concurrency in asynchronous programming. That's where we need to focus our attention, and that's what we need to understand is what are the problems that we are facing here. So what are the tools that we can use as a way to handle this asynchronicity? First is the callbacks, which is now this particular tool that the web platform provide. This is not JavaScript. Okay, so set timeouts. Okay, this is a way of how you can now is make this code run at some point in the future. So it's the continuation of a program at some point in the future. This is something important to remember. So this continuation of these programs at some point in the future is now encapsulating in this particular way. If you want to actually is, well, I want you to do this task, and when that task is done, I want you to do then this next task, and then the another task, and so on and so forth. So a lot of people say that this is now a called the pyramid of Zoom, because this is then you get is now all of these nested timers, which of course is not great for readability. However, the problem here is that how we're going to handle is concurrency, because a lot of people complain about this pyramid of Doom as part of the problem, all right, where the whole problem here is not that, because you can actually clear this and make these things much more easy. The problem here lies is on how we're going to now write our applications, asynchronous applications. How we're going to handle this concurrency in our asynchronous application in a way that is similar as how we write our code, similar as how as human we cannot perceive that code. So in my particular case, we look at this problem here. Okay, this is one of the things that actually requires you to be in your zone in here as a way to understand, right? So because the problem here is that which is a common pattern in user interface design, is like, hey, we need to doing multiple requests. We need to do multiple requests in parallel. If you're building, for example, if you're building, for example, an e-commerce application, hey, on the checkout button, you want us to send a request to your analytics, a request to your API, and perhaps a request to the payment methods as well, the payment gateway, right? And the request to a user as a way to get that user. So all of this operation that needs to happen at the same time. All right, this is a lot of time. This is a pattern that we see, especially on dealing with user interface design, which is doing multiple requests in parallel, and then waiting for them to come back. Now coordinate their response in order, and then make sure that things happen in the same order. Exactly. So the point of this is now the problems that we are facing here, especially when we need to talk to this, which is we're going to define as a user we need to make things in parallel. Then we need to wait for waiting for them to come back, and then coordinate their response in responding as soon as possible if we need to, and then coordinate in order, right? So this particular solution here when we say, hey, we are triggering is this three callbacks in parallel, all right? When here we create now this particular function, but the thing here is that this was not the function that we wanted to show here. In fact, is this. It's like, hey, we wanted to know how we going to handle is this, right? How we going to handle is this async operations, waiting for the response, waiting for them to come back, okay? Only using JavaScript, waiting for them to come back, and then coordinating the response, managing is and responding them accordingly, and then we can now to maintain the order at which those async tasks responds. So this is not something trivial to do this, and that's what we have here. For example, is a global object that will hold is all of this particular reference of our requests, okay? And by the time they come back, we need to find a ways to sort them in the proper order, or to control the sorting in the proper order. So here we use, for example, is an array as a way to make that happen. But again, a very simple example here with this array. So anytime we actually are checking is in our array in the proper order, right? If they come in the proper order, so if we have now all of our response stores in the proper order, all right, then is when we're going to now call this and show that to render that out, to render the output. So this is a lot of mechanism here, and again, this is just one particular way of doing this. Holy F. You know, because there's several ways of doing this. Okay, so the pain points of doing this, right, or the idea of looking at now how this callback is not a, even though that you can now write your applications with plain callback as a way to handle all of this concurrency in your async applications, what happened here is that not only that it's ugly, that you need to then figuring out what is the best and optimal way of doing this. This actually solve your own problems. This completely solve your own problems because you are now having all of these responses stored into a hash map, into a record. When you say, all right, when they arrive, when all of these responses are done, and I am hard coding this, by the way, then is when I have now show them in proper order. And then you need to also handle is garbage collectors. It's like, hey, this response that we get from we need to find a way to actually is make it eligible to be collected by the GC. You know, all right. And again, this is just one particular solution. One particular solution. So let's get into this. So another problem as well is another problem if you read about this. Especially for the callback, right? Is that by the time you are reading is this here, you say, okay, let's go. Let me call now this fake response URL. Let me actually pass this data to this. So far so good. But to this what? To this CB. What is this CB? Well, it is a callback that I'm passing here from this function. Okay, function here that it will at some random point in this case as a way to imitate is async operations for that. At some point, okay, we are now going to actually call them, which is in or here, right? So this is something that is Again, this back and forward and looking and reading in there is like this lack of this lack of reading line by line, similar as when we're reading a particularly text. Okay, even though you're Japanese or the Asians, you read that one sequence at a time, whether it is top to bottom, or in the case of the West, left to right, or in the case of the Middle East, it's from right to left. We as human, we need to do this writing. We make sense of this by sequence. So let's get into this.
So I've alluded to this already. Let's try to be more articulate about the two major problems of callback hell. We saw the symptoms of them. The symptoms of callback hell were that managing that time state complexity was rather awful. It's very manual, it's very hard coded, it's hard to do. But there's something deeper even than that. So to try to articulate those two problems, I'm going to have to take some conceptual steps back, a little further away from the code. First, I want to talk to you about a principle called inversion of control. By the way, if you do a search for inversion of control, you're going to get lots of different answers in different software domains as to what inversion of control means. So try not to confuse all those different overloaded definitions with the one that I'm going to give you here. What I'm going to give you here is that inversion of control means there's part of my program that I'm in control of executing, and then there's another portion of my code that I'm not in control of executing. And the way that we express that is to take the first half of my program that executes now, and the second half of my code that executes in a callback, and when I give that callback to somebody else, that's what inverts the control, and it puts them in control of when and in what manner to execute the second half of my program. That's all and only what I mean by inversion of control.
Inversion control. Okay.
I'm going to assert to you that this is one of the two evils of callback hell, this notion of inversion of control. So let's go back to this fundamental set timeout. There's a line 1 and a line 2. Those represent the first.
And this is one of the two, again, it's one of the two problems, especially by the time you are running these functions, right?
I'm in control of executing. I'm going to give you here. What I'm going to give you here is that inversion of control means there's part of my program that I'm in control of executing.
Exactly. So let's think about it. The callback problem, inversion of control. Not reasonable. So callbacks problem. Callbacks problems. So callbacks problems. Inversion of control. Inversion of control. That's right. That's right. Really? Okay. Is it callbacks? Problem of inversion control. So there's a part of a program that I am in control of executing, exactly. So there is a part of my program that I am in control when executing. That I'm in control of executing, but.
And then there's another portion of my code.
And there is another portion of my code that I'm not in control of executing. And there is another portion of my code that I am not in control of executing. Okay.
That I'm not in control of executing. And the way that we express that is to take the first half of my program that
and the way to express that is to take the first half of my program, use a callbacks, and pass this another portion to that.
Executes now, and the second half of my code that executes in a callback.
Exactly. The way to express that is to the first portion of my code
that I'm not in control of executing. And the way that we express that is to take the first half of my program that executes now,
Is the way to express it is to is that it takes.
And then there's another portion of my code that I'm not in control of executing. And the way that we express that is to take the first half of my program.
Okay, and the way to express it is that it takes the first half of my program. It takes the first half of my program and execute it. Execute it.
That executes now, and
exactly, and execute now, and there is the half code of my executed that execute
the second half of my code that executes in a callback.
And the second half of my code that is executed in a callback.
And when I give that callback to somebody else, that's what inverts the control. And
and when I give that portion to a callback, that's when it invert the control of my program.
Puts them in control of when and in what manner to execute the second half of my program. That's all and only what I mean. That's what inverts the control, and it puts them in control of when and in what manner to execute the second.
And it inverts it, exactly, and it gives that portion to a callback that decide
that executes in a callback, and when I give that callback to somebody else, that's what inverts the.
That's when it invert the control. Inverts the control. Okay, that's where invert the control and put them. And it puts them in control of when, and it puts them in control of when and how that portion will execute.
Control, and it puts them in control of when and in what manner to execute the second half of my program.
And when and how it will execute that time, that second half of my program. Makes a lot of sense. So the idea here is like you are passing the ball. It's pretty much like you're passing the ball to that, and you certainly expect that it will throw you the ball back, right? But this is a very interesting here cycle. So there is a portion that I am in control that is executing now, and a portion and another portion of my code that I am not in control of executing. And the way to express that is by taking the first half of my programs and execute now, and the second half of that is executed in the callbacks. And when I give this portion of this, and when I give this portion to a callback, that's when the inverts the control. So it puts them in control of how and when this executing, how and when it will execute the second half of the program.
That's all.
Do you really understand that based on all this jargon? In simple terms, you have now a portion of your code that you are in control, also another portion of control, another portion of code, or you have a first half of code that you are in control, and then you have a second half of the code that you are not in control. And when you're executing the first portion of code that you are in control, now the way to express this is by passing or the way to express this inversion of control is by passing the second half of the code to a callback, and that's when the inverted controls happen. And that's what the inverted control is. You puts them in control of when and how the second half of the code is executed. Makes a lot of freaking sense. Makes a lot of freaking sense, bro. Jesus. Oh my god. Oh my god. Oh my god. Oh my god. Okay.
And only what I mean by inversion of control. Okay? I'm going to assert to you that this is one of the two evils of callback hell, this notion of inversion of control. So let's go back to this fundamental set timeout. There's a line 1 and a line 2. Those represent the first half of our program. Lines 3 and 4 represent the second half of our program. We are in control of lines 1 and 2. They're happening now. We are observing them happening now. We are in control of them. Lines 3 and 4 are going to happen at some unspecified later time, and we are completely not in control of how and when those lines get executed. We have given that control over to someone else. In this case, it's the set timeout utility. It is entirely in control of when and if this ever even gets executed. All right? Now, with a set timeout, that's a built-in JavaScript engine facility, and even though there's some weirdnesses around timers, we can all probably say we don't worry too much. We don't have a trust issue around the timer not calling the callback or doing something weird. So let me give you a slightly different scenario. What if it's not the built-in engine? What if it's some other utility, maybe even a utility that comes to you by way of a third-party library? Let me give you a scenario. I'll set this up because I like to teach.
Okay. So here we are using is the utility provided by the language, provided by the platform, by the web platform. So we can now be sure that that code will be executed at 1,000 milliseconds. Exactly, that code will be executed 1,000 milliseconds, effectively passing down the control of my code to passing down the control of my code of line 1 and 2 to them, so they decide when to run this, when and how. So they decide when and how to execute line 3 and 4. So there is no trust issues with this, since you and I can trust of the web platform.
Just do silly metaphors and scenarios and things. Okay, so let's imagine that you are tasked with building an e-commerce engine for your company. Your company sells high-end, expensive TVs to celebrities, $10,000 TVs to celebrities. You're tasked with building the e-commerce site that sells those to people. So you go through all the work of making this e-commerce site, all the cart and all that other stuff. And the very last step of the e-commerce checkout, right as the person is clicking the checkout button, you have a third-party utility like an Omniture or something like that. They've provided you some utility called track checkout, which you need to call with the details, the order details, and they will track that in the analytics so that your marketing folks know what's happening and your product folks know what's happening. They're going to track that purchase info asynchronously, and then they're going to call your callback to let you know that it's time for you to go ahead and charge the customer's credit card and print the thank you page. So it's the last step of the puzzle, okay? Everything seems great. You write this code, it's pretty straightforward. The API makes sense. I pass in this callback. You test it against their test bed, and everything works great. So you go live. And day one, celebrities start buying your awesome $10,000 TVs, and everybody from the CEO all the way down to you is happy at the company. So we fast forward in this scenario 6 months. One morning before work, you're sitting at a coffee shop, casually sipping on a latte, and you get a call from your boss. And when you pick up, your boss is not usual casual self. Complete panic, can barely form full sentences. Says, there's a major crisis, huge PR problem. George Clooney tried to buy a TV on our site, and his credit card was charged 5 times for the same TV. And then he tweeted about it, and now a bunch of people are, complaining about our site, and blah, blah, blah. It's a huge PR nightmare. You got to rush into work right now. Your head's spinning. You don't even remember writing this code, but you rush into work, and your boss says, well, they've refunded his credit card, but we still have this huge, PR nightmare that we're working through. But as engineers, we've been told we have to figure out how this happened and make sure it never happens again. Sound familiar to you? You've probably had your own version of.
Making you talk about is you talk a lot of this kind of thing, but it's like it impact on your image, it impact on your. It's a huge PR nightmare, and it is funny because it's like not only for that company but also for yourself, because at the end of the day, you're not only you're part of the company, but also if you can extrapolate this a little bit, and I know I'm taking a quick tangent here. I'm gonna get it back here. If you now apply that to your life, especially when you are doing the thing that you need to do, but you're not, okay? So a good example of this is like if you don't eat well, if you don't eat healthy, but you want to actually look good at the mirror, feel good, more likely, feel good with yourself. But you're not doing the thing that you need to do, you're going to get these particular outcomes. And it's all about yourself, right? Because you weren't diligent enough, diligent. Diligent, exactly. You weren't diligent, exactly. Diligent, yes. Diligent, exactly. So you weren't diligent, okay? So you were diligent enough to actually understand. So you were diligent, exactly. You were diligent enough to understand what's going on and how to do that, and then you get the outcomes here. And this is just for the point of view of yourself, right? And if you can imagine that as a company, it's like, oh my God, that'll be something pretty effed up for that. This is a huge pH nightmare.
Fire that you get told you have to make sure this never happens again. Yeah, sorry for your PTSD if I'm triggering memories for you, right? But we can identify with this because this is how software works. Works great until there's some huge fire, and then all of a sudden our eyes are open to a set of problems that we didn't even know existed. Or maybe we thought existed, but we really hoped we'd never run into, and then we did, okay? In this case, you didn't even realize there was a problem.
That's one of the things that, or then you realize that there's a huge new range of problems that are coming with your software. And this is everything, exactly. Everything works well until it's not, in the case of software. So you now writing your code in a very tactical way, exactly. You're writing your code in a very tactical way, right? But then suddenly a lot of problems come up here. And then you hopefully don't want to deal with them or find some way to actually avoid it. But the problem is still there. Holy crap. But the problem is still there.
Obvious, clear case of what the problem is. You don't even remember writing the code, but you go pouring over your code that afternoon, you're looking through stuff, you arrive at this part of your code, and you see that's the only place where we charge the customer's credit card. And you try to check, well, could he maybe have clicked the button 5 times, but you already have code in there to fix that, and what could possibly be the problem? You arrive eventually at the conclusion that there's no other possible way for the credit card to have been charged 5 times other than for the track checkout utility to have called your callback 5 times. It's the only logical conclusion. You scour their documentation, there's not a single mention of them calling your callback multiple times. So you call up customer support and you say, I got this huge PR issue, need you to help me out. Seems like this callback has been called multiple times and I don't see any part of your documentation. Well, the support representative is similarly surprised, scours their documentation, never heard of it, got no idea. So we'll escalate it to our top tier support and we'll get back with you with a resolution. You got nothing else to do. So you go home for the day, you come back the next morning, and in your email, first thing, you have this long email, this long detailed email. It's kind of like when a company has a security breach and they put out their blog post that shows how everything happened. They're like, at 9:02, we discovered this, and at 9:18, we shut this off. It's this big, long email describing everything, but what it boils down to is they say that some of our engineers were working on an experimental branch of the code where they were going to try to call your callback, and if they didn't hear a successful return value from your callback, they would try once per second for 5 seconds, and then eventually fail out, time out after 5 seconds. Now this was experimental code. It was never supposed to go live, but there was a breakdown in our process, it accidentally went live. It was only live for like 5 minutes before we'd rolled it back, but it just happened to be the 5 minutes that your site got caught in it. We've checked all of our processes, we've implemented all this stuff, and we promise you this will never happen again. Okay? That's the resolution. You print out that email, you take it to your boss, you're like, this is what we got. They say it was their fault, they called our callback. Your boss looks at you. And it's at this point in the story that I want to ask you, what are the chances that your boss's response is going to be, oh, sounds good to me? I would say approximately 0.
Yeah, yeah. You know
because
what would be the chance that what would be the chance that your boss say when you take it, you explain that is, yeah, whatever.
Ask you, what are the chances that your boss's response is going to be, oh, sounds good to me?
Yeah, what is the sound? What is the chance of your boss? Oh, what is the chance of your boss response? Sounds like, that sounds to me. That sounds good to me.
I would say approximately 0. Because at this point, what has been exposed about your system is something you didn't even realize before. You did not realize that there was a trust point when you passed in a callback. When you pass in a callback, you are trusting that that callback will be not called too many times or too few times or whatever. So then you think, well, what do I got to do to fix this? Because your boss is going to be like, you got to make sure that can never happen again. Well, the light bulb goes off in your head and you say, oh, I'm brilliant, I got an idea. I'll set up a Boolean flag. It'll start out as false. First time it goes through, I'll flip it to true, and I'll make sure that that darn thing, no matter how many times they call it, I'll only ever charge the credit card once. You feel pretty good about yourself, right? You're like, this is awesome. So you check in that, sure that will not. You did not realize that there was a trust point when you pass. Well, what do I got to do to fix this? Because when you pass in a callback, you are trusting that that callback will be not called too many times or too few times or whatever. So then you think, well, what do I got to do to fix this? Because your boss is going to be like, you got to make sure that can never happen again. Well, the light bulb goes off in your head and you say, oh, I'm brilliant, I got an idea. I'll set up a Boolean flag. It'll start out as false. First time it goes through, I'll flip it to true, and I'll make sure that that darn thing, no matter how many times they call it, I'll only ever charge the credit card once. You feel pretty good about yourself, right? You're like, this is awesome. So you check in that code, you produce a test case for this, you go to the QA department. Now I'm about to bash on a QA department, but it's lovingly, so I apologize if you're in QA. Everybody loves QA. We love to hate them, but we need QA, we need you, right? So you go to the QA department, you say, I got this fix for the bug, here's the reproduce case, blah, blah, blah. And then that QA person does what they always annoyingly do. They ask you that question that you didn't even occur to you, you didn't want them to ask, because he says, well, what about if they never call our callback? Do we have any code in there for that? Nope. So now you're starting to panic, like, no, I don't have a solution for that problem, but I guess I could set up some kind of timeout for that or whatever. And then he goes on, he says, well, what about all the other places in our code that we use callbacks? Do we have fixes for all of this in all of those places? And you get that blank stare on your face, and you're like, maybe I can slowly back away and pretend I did not hear him say it. Maybe I just can pretend I didn't hear any of this, right? Because all of a sudden what's been exposed is how deep this rabbit hole goes. The trust issues that...
And it is interesting is that by explaining is now this particular process of how you're going to create an e-commerce, and then that e-commerce is like, what in the fucking hell? Are you naked, bro? Oh no, almost. But now by explaining is that... Anyway, but now by explaining is that this particular issue here is with the inversion control, and then now a very interesting way of saying, hey, if you're gonna build an e-commerce, which is something that this is in today's economy, it is what it is. If you're gonna build an e-commerce, right, that's for some reason you build all of the user interface, and you're doing this for a company, and you put everything in place, you show all of his products, that kind of things, and then by the time of the checkout, now you are relying is on a utility library to handle this check. So this utility library is as a way for that particularly open source code or code to now keep track of their marketing as a way to how many times is this being called, and also how many times they are charging that things, right? So you now use these utilities, so you put that, so you run the test, you test that, and the test also pass, good, and then now then it goes live. So that's good, so great. 6 months later, you are 6 months later, or it can be now, right now, it can be 3 weeks later. It can be now that you're sitting at the comfortable. So you're sitting comfortable in some sort of cafe, enjoying your lovely cappuccino and life, and then well, you realize that your boss is calling you, and it is off himself as usual, off casual self. So he is not casual self. He's panicking, or he's perhaps screaming at you and telling you, "Hey, we actually is now overcharging his Kanye West for selling his 6 times. We charge the credit card. We charge the Canny credit card 6 times for purchasing a smart EV, and now, of course, we need to find a way to fix this, right?" So then well, of course, you put your butt to work. You understand what's happening, then you know that you can actually tell to the payment providers to say, "Hey, I want you to now is at some point is refund that, right? Well, that was an error from our side, and then you now analyze your code. You are quite sure that your code works as expected. You actually do all of this heuristics and introspection of your code, and then now at this particular point of the track checkout, right, because this is part of the utility function that you are using to handle that, you now come to the conclusion, to logical conclusion, to say, "Hey, yes, this is not this is not my fault. This is, in fact, is some of the way of how now this library are handling is this." So you go out to the documentation, you do, so you're scouring that, you couldn't find anything that particular application is now triggering, or the way how it is handling is this checkout, and then you ask to their customer service, and they say, "Hey, yes, this is something that we experienced. So we actually charge 5 times to this in this particular case. We want to know what went wrong." So now customer support say, "Okay, Lord, let me now is raise that to let me now to raise this to the proper HR department, or in this case, let me raise this concern to the proper department." The proper department actually is on their side, on the development side, and then they say that, well, they have some troubles in handling this particular problem. They actually fix that, okay, and you now say, "Hey, even though that now they have to solve that, I want to now find a way to actually make sure that this actually works as expected." So you decide to put a boolean there that say has been called. All right. And by the time you do that, right, and then you now put this code to test. So we actually go through the QA, and the QA say, yeah, hey, good, right. Is this code that you're putting here actually is work with callbacks? And is this the way how we actually handling all of the callbacks in our application? And then he started to ask questions that how deep is this rabbit hole when you started to actually now dealing with this small checkout and now the problems that you are actually facing here.
We're involved in passing a callback, the inversion of control trust issues. We were trusting that when we pass a callback to some other utility, by the way, it doesn't have to be a third-party utility. It could be somewhere else in your same program, even stuff that you wrote, okay? But we pass it in and we trust that it won't call too early, not too late, not too many times, not too few times, won't lose out on any of the context that it needs to pass in, and won't swallow any errors that may have occurred. And actually the list just goes on and on and on. These are all things that you have been implicitly trusting every single time you've ever passed a callback anywhere in any JavaScript program you've ever written. Until this moment, most of you have probably never asked the question, what happens if this trust falls apart? It's interesting to me that it was never supposed to go live, but there was a breakdown in our process and accidentally went live. It was only live for like 5 minutes before we rolled it back, but it just happened to be the surprise. It existed, but visual casual self, complete panic, can barely form full sentences. Says, there's a major crisis, huge PR problem. George Clooney tried to buy a TV on our site, and his credit card was charged 5 times for the same TV. And then he tweeted about it, and now a bunch of people are, complaining about our site and blah, blah, blah. It's a huge PR nightmare. You got to rush into work right now. Your head's spinning. You don't even remember writing this code, but you rush into work, and your boss says, well, they've refunded his credit card, but we still have this huge, PR nightmare that we're working through. But as engineers, we've been told we have to figure out how this happened and make sure it never happens again. Sound familiar to you? You probably had your own version of a fire that you get told you have to make sure this never happens again. Yeah, sorry for your PTSD if I'm triggering memories for you, right? But we can identify with this because this is how software works. Works great until there's some huge fire, and then all of a sudden our eyes are open to a set of problems that we didn't even know existed. Or maybe we thought existed, but we really hoped we'd never run into, and then we did, okay? In this case, you didn't even realize there was a problem. There's no obvious, so you call up customer support, and you send a long email, this long detailed email. You feel pretty good about yourself, right? You're like, this is awesome. So you check in that code, you produce a test case for this, you go to the QA department. Now I'm about to bash on a QA department, but it's lovingly, so I apologize if you're in QA. Everybody loves QA. We love to hate them, but we need QA, we need you, right? So you go to the QA department, you say, I got this fix for the bug, here's the reproduce case, blah, blah, blah. And then that QA person does what they always annoyingly do. They ask you that question that didn't even occur to you, you didn't want them to ask, because he says, well, what about if they never call our callback? Do we have any code in there for that? Nope. So now you're starting to panic like, no, I don't have a solution for that problem, but I guess I could set up some kind of timeout for that or whatever. And then he goes on, he says, well, what about all the other places in our code that we use callbacks? Do we have fixes for all of this in all of those places? And you get that blank stare on your face and you're like, maybe I can slowly back away and pretend I did not hear him say it. Maybe I just can pretend I didn't hear any of this, right? Because all of a sudden what's been exposed is how deep this rabbit hole goes. The trust issues that were involved in passing a callback, the inversion of control trust issues. We were trusting that when we pass a callback to some other utility, and by the way, it doesn't have to be a third-party utility. It could be somewhere else in your same program, even stuff that you wrote, okay? But we pass it in and we trust that it won't call too early, not too late, not too many times, not too few times, won't lose out on any of the context that needs to pass in, and won't swallow any errors that may have occurred. And actually the list just goes on and on and on. These are all things that you have been implicitly trusting every single time you've ever passed a callback anywhere in any JavaScript program you've ever written. Until this moment, most of you have probably never asked the question, what happens if this trust falls apart? It's interesting to me that developers are actually pretty good at understanding why it's important to have that like trust but verify thing with what's passed in. Like, when you have a function that's supposed to add 2 numbers and you assert that they are actually numbers before trying to add them together. We're pretty good at mindsets like that. And we've never once implemented any notion of checking that our callbacks are behaving the way that we expect until we run into this problem. So this is how I would say it. If you've ever had a callback in any JavaScript program that you've ever written and you do not have a solution in place for every single one of these trust issues, that program currently has a bug even if you've not been bitten by it yet. This is a fundamental deficiency in callback design, is that the callback itself does not have a solution. There is no solution for this part of callback hell, this inversion of control trust issue.
What is the solution we are doing? when using callback is this.
Our particular one was not too many times. There were quite a few others. So if you want to scramble and solve every one of those, you might be able to come up with an ad hoc solution for every single one of those and patch that one solution, and then you're going to start thinking, I got hundreds of callbacks in my program. I'm going to have to solve this ad hoc in every single place. All of a sudden, your code base just ballooned by 3 or 4x. It's completely unmaintainable and impractical at this point. We're going to need something better that's designed specifically to solve all these trust issues. The second tenet of callback help, I'm going to fundamentally declare or assert that callbacks are not reasonable. And I highlight reason to suggest. I don't mean reasonable in the sense of like likable. I mean reasonable. They are not able to be reasoned about. Let me try to illustrate. How many of you have ever heard before or said before yourself, I'm a multi...
Callbacks problem? Not reasonable.
multitasker? Anybody ever said that before? It's pretty common. People talk about it. I'm like, I'm driving down the street, I'm talking on the phone and texting, I have my laptop in the seat next to me and listening to the radio and mom's on the phone, like doing a whole bunch of stuff. I'm multitasking. Well, that's nonsense. We're not actually multitaskers. At our highest level of cognition, which is the only part that I care about right now, I'm not a neuroscientist, so I'm not really speaking as a neuroscientist, but from what I know and from what we can observe, at our highest level of cognition, our brains are fundamentally single-threaded. At any given instant, our brain is only thinking about and cognitively thinking about one exact thing. Plenty of other parts of our brain are taking care of all the other autosomic things like our heart and breathing and all that other stuff. I'm not talking about that. I'm talking about the highest level of cognition, the part where we are intentionally planning and thinking about things. And at that part, we're only thinking about one thing at that exact moment. So let's imagine this morning when you all woke up. This morning you thought to yourself, I got to plan out my day. So when you woke up, you started planning out your day like, well, I got to get some coffee and I'll hop in the shower and then I'll get on the, get in the car and drive to work and then I'll head over to this workshop. And you planned out your day in a very sequential, step-by-step fashion. Virtually all of us, our brains, we'd say that's how our brains work. We think about things in a very sequential fashion. However,
since our brains work in a very sequential fashion, right? However, callbacks doesn't work that way.
I'm also willing to bet that virtually none of you had your morning play out exactly the way you planned. You were up making some coffee, and then your mom called, so you got interrupted by that call. That wasn't part of the plan, and then this other stuff happened, and your car was out of gas, and your plan had to change. And thankfully, you didn't have, when your mom called, you'd be like, well, there's the whole day shot. I didn't plan for that, so I better just go back to bed and start up tomorrow. Your brain, thankfully, is, interestingly, a lot like the JavaScript engine in that it can be interrupted event-wise, like an event loop. You can have an event fire, and it can choose to respond and adjust. But that's not the part we care about. The part that we care about here is the part of our cognition where we plan things. And fundamentally, what I'm going to argue is that we naturally plan things in a sequential, synchronous, step-by-step fashion. So, if that's how we plan things,
especially in planning things, our brains do that in a sequential synchronous fashion. Our brain does that in a sequential, synchronous fashion.
that's also how we code, most naturally. Now, I have a theory here. This is not a law. It's as close to as proven a law as I can probably get. I have this theory that any place where our brain diverges from the way the JavaScript engine works, at that moment where the two diverge, it is at that moment that bugs happen in our code.
A theory here is that when our brain and the JavaScript engines diverge from our diverge.
That any place where our brain diverges from the way the JavaScript engine works. And
So the theory is that when our brain and the JavaScript engine diverge from how they work, that's when we that's when a bug happens, because we don't understand this machine how that works.
that moment where the two diverge, it is at that moment that bugs happen in our code. Wherever our brains diverge from the way the JavaScript engine works, I can't do anything about how the JavaScript engine works. It just works that way. I can teach you better about it, try to train your brains better, but I can also try to offer you patterns that allow you to program more naturally like your brain so that there are hopefully less bugs in the program. That's basically my theory of teaching. How do I train you to write your code so that it works more like your brain, so that there's less divergence and less bugs? So that's more reason. My theory of patterns that allow you to program more naturally like your brain so that there are hopefully less bugs in your program.
So the goal here is to how to align, or how to think.
Try to train your brains better, but I can also try to offer you patterns that allow you to program more naturally like your brain so that there are hopefully less bugs in your program.
So the goal of here is to teach us, or is to learn patterns about how our brains works as the
Try to train your brains better, but I can also try to offer you patterns that allow you to program more naturally like your brain so that there are hopefully less bugs in your program.
So the goal here is to learn patterns that program to learn exactly. So the goal here is to learn patterns that work how your brain programs so there are less bugs in it.
That's basically my theory of teaching. How do I train you to write your code so that it works more like your brain, so that there's less divergence and less bugs? So it's more reasonable, it's more understandable. We see callbacks don't really offer us much affordance in that way, because we could think about it from a pseudo-task perspective. Like, you know what I love about pseudocode? Pseudocode's awesome because you just get to invent magical stuff out of thin air. I wish I could get paid to write pseudocode all day, because it'd be the funnest job in the world. I get to invent stuff like on line 3 where I invent pause, this magical thing that I invoke called pause, which doesn't actually exist, but it doesn't matter because this is pseudocode. And then on line, on line 9, I invent this other thing that also doesn't exist called resume. I just magically pick up where line 3 left off, right? That's how I'd write this out in pseudocode. But as soon as a developer got hold of me, he said, oh, no, this, you're just making stuff up. This is not how it works. So they begin to rearrange things, and they might rearrange the pseudocode like that. They say, well, we can do this pause and resume thing, and then a pause and resume. And do you see what we've done now? We've started to implement this as a series of nested callbacks. Because callbacks alone, that's the only way for us to express, and listen, here's a fancy term for you, temporal dependency. When one thing depends upon another thing finishing before this thing can go, that's a temporal dependency. And the only way with callbacks for us to express temporal dependency is nesting one inside of the other, the call to one inside of the call to the other. Whether we do so with inline function expressions or with just the function calls, the only way to handle temporal dependency in callbacks alone is through nesting. Well, why is that such a problem? The reason it's such a problem is now your brain doesn't get to linearly progress through the code. Your brain has to do what I call non-local jumps. Here's a metaphor for you. How many of you remember, way back, I'm talking like mid-80s, the original Nintendo? And my favorite game of all time on the original Nintendo, Legend of Zelda. Anybody remember playing? I had to leave the thing running, forever and play it. It would take weeks to play through or whatever. You know what I loved about that game, though? There's this one part. You would go into a cave, and all of a sudden the screen would go completely black, except for this tiny little circle around Link where he's holding his torch up. And you can see just a small little portion of the map at any given moment. Now, you could move Link all over the cave. You could see the entire map, but only this little circle at a time. You could not see the entire thing all at once. That's what modern JavaScript programming is today. Modern asynchronous JavaScript programming. Now, this is not a knock on any individual person listening to this to suggest that you are just fundamentally bad programmers. We are all limited in this fashion, that the complexity of asynchronous flow control that happens in our programs, there is no developer on your team that understands all of those flow paths. It's beyond our capacity to understand. You might get step 1, then step 2, then step 3, but as soon as you get like step 1, 2, and 3 at the same time, and when these two finish, fire off here and there, you're completely lost. You can understand
completely, exactly. And this is one of the things that happens a lot of the time, especially when you are handling with this. A lot of this asynchronicity, man. A lot of this asynchronicity.
Complexity of asynchronous flow control that happens in our programs, there is no developer on your team that understands all of those flow paths. It's beyond our capacity to understand. You might get step 1, then step 2, then step 3, but as soon as you get like step 1, 2, and 3 at the same time, and when these two finish, fire off here and there.
Exactly. So you might understand is that step 1, step 2, and step 3, it might work like a charm for you, but when you now do step 1, 2, all of the 3 things gonna do that, and then after that I want to do this kind of jumps.
It's beyond our capacity to understand. You might get step 1, then step 2, then step 3, but as soon as you get like step 1, 2, and 3 at the same time, and when these
step 1, 2, 3 at the same time,
finish, fire off here,
and there's 2, 3 fires after the another one.
Here and there, you're completely lost.
Which is what happened here, and I think that when you started to reading these particular code bases, and understand how all of these things, how all of the things work, you realize that a lot of the time is handling is this kind of complexity, is in jumping forward code that is actually something that is very, very heavy. It produces cognitive burden.
You can understand only just this small little portion. You get that, and then you move over here and you understand this part, and then you move over here and you understand this part.
But you do that in a synchronous way.
Heaven forbid when those parts are where the callbacks are jumping around between the files of your program, and you are fundamentally not able to plan out your program the way your brain works. Because callbacks alone don't have a way of expressing things in a sequential, synchronous-looking fashion. It seems like it's almost impossible to do, doesn't it? Doesn't that seem like almost a unicorn? Like, there's no way to do asynchronous coding in a synchronous fashion. That's like having false be true at the same time. That seems impossible. Well, I'm going to all the trouble to talk about this to suggest actually it is quite possible. But that's why we need a better pattern. Because what we need to do to solve callback hell is to be able to express our code in a synchronous sequential fashion the way our brains think. So when we write code like that, first half of my program, then the second half of my program, and we think to ourselves that it's like blocking 1,000 milliseconds, which doesn't really exist, and the JavaScript engine says, actually, I'm going to do a whole bunch of other stuff during that. What we need to do is restore the ability to express things in a synchronous sequential looking fashion. That's the other part of callback hell that we need to fix. Naturally planned. This morning, when you all woke up, this morning you thought to yourself, I got to plan out my day. So when you woke up, you started planning out your day like, well, I got to get some coffee and I'll hop in the shower and then I'll get on the, get in the car and drive to work, and then I'll head over to this workshop. And you planned out your day in a very sequential, step-by-step fashion. Virtually all of us, our brains, we'd say that's how our brains work. We think about things in a very sequential fashion. Line 3 left off, right? That's a dependency in callbacks alone. Favorite game of all time on the original Nintendo, Legend of Zelda. Anybody remember? But only get like to plan, like there's no to do to solve, which doesn't really exist. And the JavaScript engine says, actually, I'm going to do a whole bunch of other stuff. We write code like that, first half of my program, then the second half of my program, and we think to ourselves that it's like blocking 1,000 milliseconds, which doesn't really exist. And the JavaScript engine says, actually, I'm going to do a whole bunch of other stuff during that. What we need to do is restore the ability to express things in a synchronous, sequential looking fashion. That's the other part of callback hell that we need to fix, to make our synchronous code fundamentally more
our synchronous code fundamentally.
There's a bunch of non-fixes that have been attempted with callbacks. I call them non-fixes because they're attempts at fixing which actually did nothing but make it worse. So, for example, in the callback world, we invented this pattern of split callbacks. If our problem that we're trying to solve is that we've got an error that we don't want to get swallowed in case there's some problem with the main function, we're like, oh, I know, I'll just pass a separate callback for my errors. And that way, if there is some error, at least I know that utility will have some way of notifying me that there was a problem, right? Sounds good on the surface. Until you realize this actually makes the trust issue a lot worse. Because now you have to ask yourself, what happens if they call neither of these functions? What happens if they call both of these functions? Maybe they call the error first and then the success. Or maybe they call the success first and then the error. How's your program going to handle that? I bet some of you have code like this and you don't have any solution for that yet. It actually made the problem worse. There's more trust issues. So split callbacks, while it sounded good on the surface, actually was a regression. It took us away from a good solution. In the node world, we invented what oftentimes referred to as node style. I like to call error first style callbacks. I say, well, let's go back to one callback. 2 callbacks is crazy. Let's go back to 1 callback. But we'll reserve the first parameter of that callback for the error signal. So if it's an error that we're signaling, we'll always set that one and nothing else. And if it's not an error, then we'll leave that falsy. And so every single node callback that you've ever written has this if-else jazz going on in it, where you're checking to see whether or not it's an error condition or not. So it seems like it solved the problem about the split callbacks thing until you realize actually the same questions occur here. What happens if the utility in question does not behave the way you expect? What happens if it calls your callback twice, once with the error and once with not the error? Or what happens if it calls with both the error and the success parameters? How do you interpret that situation? All the same trust issues are at play. We are not fundamentally in control of the callback, which means we have inverted all that control and given it away to somebody else. So these are really non-fixes. Now I've got a silly running example. How many of you recognize the reference to the meaning of life? Hopefully I'm not so old that I'm the only one that knows about Hitchhiker's Guide. If you don't know about that, go read Wikipedia. Something, get up to speed on it. Silly example, calculating the meaning of life using nested callbacks. There's my fake AJAX call, my get data function. You notice it takes in a piece of data, like a number, and then after 1,000 milliseconds, it calls whatever callback I provided and just sends the data right back. So I pretend to ask for the answer, it's a calculation of value 10. 1,000 milliseconds later, the function's called and num1 is the value 10. Now x is equal to 1 plus 10, so x is 11. And then I make the call to 30. You notice that this is sequential calling. I've nested these calls together because they have a temporal dependency. I can't calculate 31 until after I've calculated 11. And then after both of those have been calculated, then I put the 2 together, meaning of life 42. I ask for that I ask for that to be computed, and 1,000 milliseconds later I get my answer back, meaning of life 42. Yeah, sorry. We're talking about lines 5 and line 7 for the get data calls, line 9 for the get data call of meaning of life. And then finally the answer is coming back on line 11. Thankfully, mine only took 1,000 milliseconds or 3 instead of trillions of years or whatever. That'd be a pretty big number for the set timer. But you see here, I have the nested callbacks, and I have all the problems of this is non-local, non-sequential reasoning even. Yes, I can move through the pyramid, but what happens when I move one of those callbacks into another module of my utility? Now I've got this non-local jump over to some other location.
I got this non-local jump to another one.
And I have all the trust issues of inversion of control. All right, let's talk about a pattern on top of callbacks. This has actually been around for a really, really long time. It way predates JavaScript.
Mm-hmm. And it makes a lot of sense with this.
There's a bunch of
okay, this is non-fixes. And they call this like non-fixes. This is now non-fixes. Non-fixes. Exactly. It's like non-fixes. This is our patterns. Okay, it makes a lot of sense. But this is our patterns, right? And I get it what this a lot of companies actually asking for. It's like, do you know all of these things? Do you really know all of this? Do you know what are the problems that we're trying to solve? Mr. Engineer. You know what I mean? Patterns. Right? Patterns. This is now async. Some async pattern some async pattern to try to solve this. So you have now the async pattern. Okay. Separate callbacks, and then you have the error first style.
That we have non-fixes. Now I've got a silly running example. How many of you recognize the reference to the meaning of life and the success parameters? How do you interpret that situation? All the same trust issues are at play. We are not fundamentally in control of the callback, which means we have inverted all that control and given it away to somebody else. So these are really non-fixes. Now I've got a silly running example. How many of you recognize the reference to the meaning of life? Hopefully I'm not so old that I'm the only one that knows about Hitchhiker's Guide. If you don't know about that, go read Wikipedia. Something, get up to speed on it. Silly example, calculating the meaning of life using nested callbacks. There's my fake Ajax call, my get data function. You notice it takes in a piece of data, like a number, and then after 1,000 milliseconds, it calls whatever callback I provided and just sends the data right back. So I pretend to ask for the answer, the calculation of value 10. 1,000 milliseconds later, the function's called and num1 is the value 10. Now x is equal to 1 plus 10, so x is 11. And then I make the call to 30. You notice that this is sequential calling. I've nested these calls together because they have a temporal dependency. I can't calculate 31 until after I've calculated 11. And then after both of those have been calculated, then I put the two together, meaning of life 42. I ask for that I ask for that to be computed, and 1,000 milliseconds later, I get my answer back, meaning of life 42. Yeah, sorry. We're talking about lines 5 and line 7 for the get data calls, line 9 for the get data call of meaning of life. And then finally, the answer is coming back on line 11. Thankfully, mine only took 1,000 milliseconds or 3 instead of trillions of years or whatever. That would be a pretty big number for the set timer. But you see here, I have the nested callbacks, and I have all the problems of, this is non-local, non-sequential reasoning even. Yes, I can move through the pyramid, but what happens when I move one of those callbacks into another module of my utility? Now I've got this non-local jump over to some other location done.
So that'll be all for this video. Take care.